Okay, quick review. We are learning our three trig functions. Well, we have 6 of them, but the three main ones are sine, cosine, and tangent. Those go along with our acronym, the SOHCAHTOA. I want you to find what cosine alpha, telling you that cosine alpha equals 3/5. I want you to find out what sine alpha is and tangent alpha. So this symbol right here is the alpha symbol. It's just another Greek letter. It's kind of like theta. We could put theta in there. We could put alpha. You could put a letter. It's just something that represents the angle measure. So to begin with, we've got to make sure we label the signs of our triangle correctly. So remember, the cosine is considered the adjacent side over the hypotenuse. So when I come over here and I'm standing at alpha, the hypotenuse is always across from the right angle, so this side has to be 5, and then that means this is the adjacent side of 3. I'll do the Pythagorean theorem to find the missing side. So you may already know this. It's a 3, 4, 5 triangle, but you can do the Pythagorean theorem to find the missing side. 3 squared plus x squared equals the hypotenuse squared. So x squared equals 25 minus 9, which gives you x equals square root of 16, and so you end up with that being a side length of 4. So it's a 3, 4, 5 triangle. So sine alpha then would be considered opposite side, which is 4, over the hypotenuse, which is 5. And tangent alpha is opposite side over adjacent side. So that's just using our three trig functions. Make sure we just label correctly the side lengths according to the trig definitions. Okay, so degrees are not the only way that you can measure an angle. You guys are used to measuring things in degrees. Well, there's another unit of measurement that's much bigger that we can also measure angles in. And they actually use this one a little bit more in higher math than they do degrees. They'll do a lot of stuff in what they call radians. So to figure out what a radian is, there's this in-class activity that we did. So if you're watching the video, you may or may not have been in class. But what we did was we took and we measured, we drew any circle size we wanted, and we measured the radius right here. And we took a piece of string and we laid it around the outside along the circumference of our circle, and we marked off every string length. So whatever this radius from A to B was, we marked that exact same length around the circumference of the circle. So we did that all the way around, and we counted up how many lengths we did. I think I actually had everybody draw in from the center, draw those line segments. So to here, 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 and then we counted up our wedges or our radians, and we found out that we had 1, 2, 3, 4, 5, 6, and a little bit. And people were trying to guess how much of a wedge is that. Well, some people were saying about a quarter, so 6.25. Some people said it was like a third, so about 6.3. So basically we found around the outside of the circle, if we matched up that circumference, to be about, here's a nice math number for you, 6.28, which is 2 pi. So in a circle, there are 2 pi radians, or about 6.28 radians. This is what we call 1 radian. This big measurement right here. So this big wedge is 1 radian. So it kind of compares to, like, degrees would be measuring small. So like you could say, well, I was measuring the table in centimeters, and that's a small measurement. And then you could say, well, then I measured the table in meters. That's a big measurement. That's the same thing with degrees. Degrees is a small measurement, and radians is a big measurement. So we could measure this in degrees, which is about, so this in degrees, if we got our protractor out, this measurement right here would be about 57 degrees. But that's also close to 1 radian. Now, because radians and degrees are separate measures, the only way to tell the difference is with the degree symbol. So if you're talking about degrees, you have to draw the degree symbol. If you don't draw the degree symbol, then people are going to think you're talking about radians. So there's a big difference there. Okay, so let's go ahead and fill this in. It says we know that there are 360 degrees in a full rotation. What about radians? Well, how many radians are in a full rotation? There are about 6.28. About how many radians are in a half a rotation? Well, a half a rotation would be half a circle. So I think that would be about 3.14. Exactly how many radians are in a full rotation? That's 2 pi. Exactly how many radians are in a half a rotation? That would be pi. Remember, a full rotation is about 360 degrees. Half a rotation, that's a semicircle, and a semicircle is 180 degrees. This is what we're going to use to convert back and forth. This is considered radians, and this is in degrees. So you can convert back and forth, just like you could say 12 inches is 1 foot. So if I said, well, 3 feet is how many inches? You would say, well, 3 feet is 36 inches. That's the same thing with radians and degrees. You can convert back and forth. You can tell me something in degree measure, and you can tell me something the same angle in a radian measure. So this is kind of just showing you what we talked about, how we determined what a radian is. What we're going to do is we're going to try to work back and forth. Now, I kind of already said that 1 radian is about 57 degrees. So I think when I convert this, I should get an answer that's close to 1. How do I do that? Well, you have to use a true conversion scale. You can't just say, well, it's about 1. I know that pi radians is about or equal to 180 degrees. That's my conversion factor. So if I want to convert back and forth, I've got to make a fraction. And those of you in chemistry, goalposts, I think is what they call them in chemistry, we've got to get it in the right order. Do I want to put pi over 180 or 180 over pi? Well, I want to convert, I already know it's 57 degrees. I want to know how many radians it is. So I want to put the radian measure on top. So the pi goes in the numerator, and the 180 degrees goes in the denominator. And so now I just go ahead and, first of all, if we want to leave it in terms of pi radian, you would just reduce the fraction 57 over 180 if it reduced. If it doesn't reduce, then you don't worry about it. So this one actually reduces to 19 pi over 60. Okay, that's what we call pi radians. This is called pi radians. Okay, but if you want to work that all the way out to a decimal, so this is our pi radian answer. If we want to work that all the way out to a decimal, then we just go ahead and say 19 pi, I'm just using the pi button on my calculator, divided by 60. And that turns out to be 0.9948 radians, which before we started, I told you on the other slide, 57 degrees is about 1 radian. Didn't say it equals 1. I said it was about 0.9948. That's about 1 radian. Okay, let's try this next one. We want to convert 90 degrees to radians. So a lot of times we just leave it in terms of pi radians. That kind of works with some of the trig stuff we're going to do later on in some coming chapters. So I've got to do a conversion factor. I know that pi radians is the same thing as 180 degrees. I got to make sure I get my fraction in the right order. So pi, I want radians, so I'm going to put pi in the numerator, 180 degrees in the denominator. That way my degree symbols reduce, they cross out. And then I just reduce the fraction 90 over 180 if I want to leave it in terms of pi. So 90 over 180 just reduces to 1/2, so I would just leave the answer as pi over 2. Okay, same thing with 330 degrees. We're going to multiply that by pi over 180. I'm in degrees. I want to go to radians. I'm going to leave my answer in what I call pi radians. So I'm just going to reduce the fraction of 330 divided by the 180. And I get 11 pi over 6. So that's 11 pi over 6 radians. We typically don't write the word radians. It's understood if you don't see a degree symbol that that angle measure is radians. That's how you tell the difference. So that's why it's so important. If you want degrees, you have to draw the degree symbol. So how do we convert from radians to degrees to go the other direction? It's still the same conversion factor. 180 degrees is the same thing as pi radians. But since I want to go to degrees, this time I'm going to put the 180 in the numerator, and I'm going to put the pi radians in the denominator. So pi and pi will reduce, and then I'll just reduce that fraction. So let's see, we end up with 315 degrees. So make sure you put your degree symbol because 315 radians is way different than 315 degrees. 11 pi over 6, if I want to convert that, I'm going to multiply by 180 degrees over pi, reduce the pi's. So then I just go 11 times 180 divided by 6, and we end up with 330, right? And we have that above in our other conversions. So remember, we're doing degrees, so I'm going to draw the degree symbol. And then down here, this one, I know this is not 3 degrees because I don't see a degree symbol. This is radians. So if I want to change it to degrees, I'm going to go 180 over pi. Now, typically, we wouldn't leave the pi in the denominator on this one. So we wouldn't write it 540 degrees over pi. You would actually continue to divide that out. So you would take your 540 and divide it by pi. And you would end up with 171.9 degrees. So that's about, so 3 radians is about 171.9 degrees. And that makes sense to me because 3.14 is a half a circle. And I know a half a circle is 180 degrees. And so I'm not quite half a circle. So I'm not quite half a circle right there. That 3.14 pi is about 180 degrees. So that makes sense. That's how we convert between radians and degrees. Okay, now what we're going to do is we're going to learn how to draw angles. So we all have to do them the same way so that we know what we're measuring and how we're measuring it. So standard position means that you always start from the positive x-axis. So when you go to draw your angle, you're always going to start on the positive x-axis. And that's going to be your initial side. So for example, I'm actually going to rotate, I'll do 120 degrees. So I'm going to do a positive angle of 120 degrees. So if I'm going to do a positive angle, I'm going to rotate counterclockwise. So I'm going to start here on the positive x-axis. I'm just kind of eyeballing this. I'm going to rotate counterclockwise 120 degrees. Okay, I started here on the positive x-axis. That's called my initial side. I ended 120 degrees, and this is going to be called the terminal side. So here's my terminal side. So in between is the angle I rotated, and since it was positive, I rotated counterclockwise, and that's 120 degrees. Now, if you want to rotate the other direction, that would be a negative. I rotated counterclockwise for positive, so I'm going to rotate clockwise for a negative angle. So let's say I'm going to do a negative 100 degrees. Okay, so that means I'm going to rotate clockwise. So start here, initial side. You always start on the initial side, but instead of rotating counterclockwise, I rotate clockwise where I think 100 degrees is. So I think it's right here. So once again, this is the initial side, and this is the terminal side. And this is considered a negative 100 degrees rotation. Okay, coterminal means it's two angles or three angles. You could have whatever, multiple angles, but they are angles that share the same terminal side. Okay, I'm going to draw a new picture. I feel like that one's got enough information on it. So I'm going to make a new axis here. So I am going to rotate, let's see, I'll rotate 150 degrees. So I'm going to do a positive 150 degrees. So positive 150 degrees is going to put me about right here. Okay, so that's a positive 150 degrees. If you rotate a negative 210, you end up on the exact same terminal side. So 150 degrees and negative 210 degrees are considered coterminal. Those are coterminal angles. They share the same terminal side. There's lots of combinations that you can get. Let's do another example. I'll do one where I do two positive angles. So it doesn't always have to be positive and negative. So here we go. I'll do a little one. So my first angle that I'm going to rotate 30 degrees. Okay, now I'm going to rotate another angle, but I have to end up with the same terminal side. So I'm going to start here, and I'm going to rotate all the way around. That's 360, and then I'm going to go 30 more. So 360 plus 30 would be 390. So the red rotation was 390. So you can say then that 30 degrees and 390 degrees are coterminal. They share the same terminal side. You could do two negative angles. You could do multiple times around the unit circle. There's infinite possibilities to come up with coterminal angles. Now, typically, if you're just going to try to figure out a positive and a negative, basically what you do is you just add and subtract 360 or add and subtract 2 pi. We'll revisit that here in a minute. Let's just quickly, this one just says, it's kind of a little bit out of order, but let's just sketch these two angles in standard position. So we've kind of been doing that already. This is 200 degrees. It's positive, so I know I'm going to rotate counterclockwise. So I'm just going to start here. I know that a half a circle is 180, so I'm going to go a little bit past that, and that's going to be 200 degrees. Okay, and negative pi over 6, if I'm going to rotate a negative pi over 6, I know I'm going to go clockwise. The problem is maybe you're not really comfortable with what is pi over 6 radians. If that 200 degrees you guys are really comfortable with. Pi over 6, not so much. So basically what you need to do is you need to put in your values at your quadrantal angles. So what do I mean by that? Usually you start here at 0 degrees, then this goes to 90, then this goes to 180, and then you go to 270, and then you end up at a full circle. So you've gone all the way around, and we call that 360. Okay, that's in degrees. You can do the same thing in radians, and that's what I'm going to do so that I can do this problem without converting. Now, I could convert that to degrees if I wanted, and maybe I'll do that at the end just so you can see, but I kind of want you to get used to doing this with radians in radians to be comfortable with that. So what I do is I decide, okay, my fractional part is sixes. I know that 180 degrees is the same thing as pi. That was our conversion factor. So instead of writing 180 degrees, I'm going to use pi. And instead of writing just pi, I'm going to use the fractional parts, and I'm going to use 6 because this fraction is out of 6's. So this would be the same thing as 6 pi over 6. And then over here, 360 degrees is the same thing as 2 pi. Well, I want it to be in fractional parts of 6, so 2 pi is the same thing as 12 pi over 6. Okay, then I would cut these in half. So this right here, half of, if I take this right here and I cut it in half, I'm going to get half of 6 is 3, so 3 pi over 6, right? And then over here, I'm going to add that and make this 9 pi over 12. Okay, so what you have to decide then is where would, let's pretend this is positive for a minute, where would 1 pi over 6 fall? Well, 1 pi over 6, this is 3 pi over 6. So that means I have to have 1, 2, 3 to get all the way around. So one of them would be about right here. That would be 1 pi over 6. Well, it's not positive. It's negative. So I need to rotate that same direction, but clockwise. So a negative 1 pi over 6 is right here. That's a negative pi over 6. So you kind of want to think of your quadrantal angles here in fractional parts. So if we want to go negative direction, so I'm going to make this so that it'll match, I first put them up in the positive direction, so now I'm going to go the negative direction. So this would be 0, and then I would come over here and I would say, well, this would be a negative 6 pi over 6. This would be a negative 9 pi over 6. And then I would come back to a negative 12 pi over 6. And then I forgot one. This one right here is a negative 3 pi over 6. Well, you can see that a negative 1 pi over 6 ends up right here in this quadrant. So you can go around and relabel those axes to help you figure out where to put your angle. Okay, so we kind of talked about this. I gave some examples. Here's another example. We're kind of switching back to the coterminal idea. So this one is showing you right here, if this original angle is 60, and if I go all the way around, like they did right here, so I went all the way around, boom, back to that, then you end up with 420. So basically, like I said, you can take whatever your angle is, and you can add or subtract 360 as many times as you want to get coterminal. And you can do the same thing if it's in radians. You can take your angle and you can add or subtract, instead of 360, 2 pi to get coterminal angles. Okay. All right, so this one says find two coterminal angles, one positive and one negative. So I'm going to start out with this one right here. I know I have a positive 225. So I basically want to go the negative direction. So this is considered the terminal side right here. So this is my terminal side. So first thing I rotated positive 225, so I'm going to rotate this way. So what would that be? Well, I think I'll take 225 and I'm going to subtract 360. So 225 minus 360 is a negative 135 degrees. So that angle rotation is a negative 135 degrees. Okay, that's a negative angle rotation, but it says to do one positive and one negative. Well, I think to get the positive one, I'm going to start on the initial side. I'm going to rotate all the way around one time, so that's 360, and then I'm going to add my 225. So I'm going to take my 225, and I'm going to add 360 to it. And that will tell you another coterminal angle of 585 degrees. Okay, so this time I'm in radians, which I know is really buggy, uh, and you should get used to working in radians. You could convert it to degrees if you want. Anytime the original problem is given in radians, you have to give your answer in radians. So if you're like, oh, I want to convert that, well, you can. You can convert it by going 180 degrees over pi, and you end up with what is that? 5 times 180. So you end up with 150 degrees. Okay, but then you're going to have to add and subtract, and then you're going to have to change everything back to radians. So we really want to get used to working with this in terms of radians. So this angle rotated 5 pi over 6 to get this direction. Well, to go this way, I would take 5 pi over 6, and instead of subtracting 360, I would subtract 2 pi, because I'm in radians. Well, get a common denominator, and subtract, and you end up with a negative 7 pi over 6. So one of your coterminal angles would be a negative 7 pi over 6. And then it says to do a positive one. Well, okay, to do a positive angle, I would start on the positive. I would start on my initial side. I would rotate around 360 degrees, and then, which is 2 pi, and then I would rotate the rest of that angle measure, that 150 degrees, which is 5 pi over 6. So to get that last answer, I would take my 5 pi over 6, and I would add 2 pi to it. Whoops. So we're going to add 2 pi, and our common denominator would be 12 pi over 6. So that turns out to be 17 pi over 6. So those would be two coterminal angles. So remember, coterminal just means you share the same terminal side. And you can do multiple angle combinations. So we won't do all of these. We'll just do one of each kind. So find a positive and a negative coterminal angle for each given angle. So I think I'll do this one right here, 450. So if I didn't want to draw this, what I would do is I'd say, okay, well, if I want a coterminal angle, I'm just going to add and subtract 360. So I could take 450 and I could add 360. And that would turn out to be 360 plus 450, 810 degrees. So 810 degrees could work. And then I'm thinking, well, I'll take 450 and I'll subtract 360. Okay, well, if you take 450 and you subtract 360, that gives you a positive 90. Well, it said I was supposed to do one positive and one negative. I ended up with two positive ones. Well, just subtract 360 again. Take your 90 degrees and minus 360 again, and you're going to end up with negative 270 degrees. And those are all coterminal with the 450. The reason why when we subtracted the 360 it didn't give us a negative is because 450 degrees is one time around plus a little bit more. It's over one revolution. So you're going to have to take out that revolution to get the 90 degrees and then do coterminal with that. So those three are all coterminal. You just needed a positive and a negative. Okay, so same thing over here. Um, let's do the negative 12 pi over 5. So same thing. We want to figure out one positive and one negative. It's in radians. So instead of adding and subtracting 360 to find the coterminal, I think I will just add and subtract 2 pi. And just for your reference, negative 12 pi over 5 is the same thing as a negative 432 degrees. So this is kind of going to act like that one above, that when I just add and subtract 2 pi, it's probably not going to give me what I'm looking for right off. One positive and one negative. I'm probably going to have to do it twice. So here's my negative 12 pi over 5. So I think I'm going to add 2 pi to that. Well, if you get a common denominator of 5, that's going to be 10 pi over 5. So 2 pi is the same thing as 10 pi over 5. Okay, so if you take a negative 12 pi and you add a positive 10 pi, that gives you a negative 2 pi over 5. Well, once again, see, this is already negative. I'm supposed to come up with a negative and a positive, right? So let's add another 2 pi to that. So a negative 2 pi over 5. Let's add another 2 pi. So that's 10 pi over 5. And if you add those two together, you end up with 8 pi over 5. Okay, do I have, here's my original. Do I have a negative 1? I do. Do I have a positive 1? I do. So I ended up with a negative angle that's coterminal and a positive angle that's coterminal. And I did it in terms of radians, so I didn't have to convert anything back and forth. So if you're looking for coterminal, just add and subtract 360 as many times as you need to, or add and subtract 2 pi as many times as you need to. Okay, to end, when this says solve the following triangle, what it means is they want you to find all the missing sides and all the missing angles. So finding the missing angle is really easy because inside a triangle adds up to 180. If you have a right angle, that's a 90. So that means the other two acute angles are complementary. So if this is 43 degrees, then this is 47 degrees. Complementary means they have to add up to 90, right? Okay, so now that I've got my angle measures, all I need to do is find the two missing sides. And you can do that with a trig function if you want. So I think I'll just stand at 47. You can stand wherever you want it. I'm just going to choose 47. So the sine of 47 is the opposite side, which is y, over the hypotenuse. And so if I solve that for y, it's 10 times the sine of 47 degrees equals y. So 10 times the sine of 47 degrees equals, so y equals 7.31. So I think I'll just go with 7.3. And then I think I'll just do cosine of 47 to find x. So the cosine of 47 degrees equals adjacent over hypotenuse. So that means 10 times the cosine of 47 degrees equals x. So 10 times the cosine of 47. And so x equals 6.8. So we found all the missing sides and all the missing angles. So over here, same thing. We know this acute angle is 22, so it'll be easy to find its complement. 90 minus 22 is 68. So we've got 68 degrees right here. I need to find these two missing sides, so it doesn't matter what I label them. I'll just call them X and Y. I think I'll stand at 22. So if I do the sine of 22 degrees equals the opposite side over the hypotenuse, y turns out to be, when you do the algebra on that, you multiply both sides by y, and you end up with y times the sine of 22 equals 7, and then you divide by the sine of 22. So y equals 7 divided by the sine of 22 degrees. Okay, so 7 divided by the sine of 22 degrees is 18.7. And then I'll just redo another one to find x. So to set that up, I'm going to say the cosine of 22 degrees equals the adjacent side x. Actually, I could do cosine, but since I did y and I found that to be 18.7, I kind of don't want to use two rounded numbers in my solution, so I think I'm going to change this to tangent. I'm going to do tangent of 22. That way I don't have to use the 18.7. It just keeps my answer a little more accurate. So I'm going to say the tangent of 22 degrees equals the opposite side over the adjacent side. And then to solve that, I'm going to multiply both sides by x. And that's going to equal 7. And then I'm going to divide by the tangent of 22. So 7 divided by the tangent of 22 degrees. And so it turns out 7 divided by the tangent of 22 degrees is 17.3. And you found all the missing sides and all the missing angles, and that's what it means to solve the triangle. Just remember to put degree symbols when you're talking about degrees, otherwise we'll just think it's radians. Coterminal means that you have to share the same terminal side. To graph things from standard position means you start with the positive x-axis and rotate around. All right, I think we're done.